So, hello, I'm Alex. This
I'm
is
Colin.
this is Colin. Colin, the managing director of Code Supply. I am just a little fun lead engineer, working on this thing we're talking about, which is the Code Supply Compensation Survey project. Um,
All right, so yeah, I guess I'll tell you a little bit about how this came into being. You've probably seen this logo around. That's Code and Supplies logo. You probably, I guess it's right there on the podium. It's inspired by some of the railroad logos of the Industrial Revolution, just the kind of motif that we're going for. Code and Supply does a lot of things. We do uh, these days we do mostly meetups. Hey, we do meetups and we do our online communities on Slack and Discord and YouTube and Mastodon and some others. Maybe one of these days we'll get back to doing one of our bigger conferences or even a smaller conference. Abstractions, you've seen some things around here. That's our really big conference brand. That's 1,500 people, all the way down to Hardfacts, which is mental health for software engineers and community building skills. Um, uh, and that's only 100 people. So right now we have knowledge sharing projects on here, and our primary knowledge sharing project is the compensation survey. We have one other thing that's like very back pocket. I like write a page on it about every month out of about total like maybe 300 pages by the time it's done. So we'll see when that actually comes together. The compensation survey is a multi-iteration effort to capture a snapshot of tech worker compensation, work-life balance, job satisfaction, commutes, where you're living, and various other aspects of what people consider to be employment. The goal of this is to help Code and Supply members and friends share their information so that they can make better decisions about their careers and their lifestyle as a software person, as a technologist. To date, dozens of people have told us how our report has helped them get pay bumps or negotiate better pay when changing jobs. I myself have cited it in negotiation twice. One time getting about a 35% increase in base pay just by having my new employer take a look at it. And the other time I got about $100,000 in short and long-term incentives, most of it long-term incentives, as a result of them realizing, oh, hey, our bid for you is way too low. So that's just my story. There's other people who have gotten raises from, there was two people that I know of who got raises from when they started from 68,000 to 80,000, basically just by saying, you're underpaying me compared to the Kinsey survey data. Compensation survey grew out of a build night idea in 2016, and I launched the first iteration in 2017 with about 256 respondents, and the analysis, the data engineering that went into it was about 500 lines of Ruby, so really not a whole lot. And that also had a lot of like spitting out markdown code in it. So it was very, very, very light on data engineering for that. We used that data to produce 2 blog posts, and then we imported the tables, the actual row data, into Apple numbers to create our graphs. Very manual, very dumb. We didn't think it was going to last we didn't think we were going to do more than one. In 2020, we decided to do it again, pre-pandemic, January 2020. We kicked off this compensation survey working group. And we recruited about a dozen volunteers to help, and the pandemic hit, and then most of the volunteers were in the wind. We still managed to get it out, though. There was a group of us, I don't know, 4 writers and probably about another 4 to 6 people who helped out with various aspects. Ran the survey, got about 750 respondents, but our process for that wasn't really repeatable. One person did all of the graphics in their own Tableau account and exported each graphic manually. That turned into, because we had 72 questions, it turned into like hundreds of graphs, and we really only ended up using about 100 of them. So it was a lot of manual work. One change meant having to re-export a whole bunch of graphs. It was not a pleasant experience. We did, however, automate the writing part of it. So whenever we built the report, we wrote it in Markdown, and we compiled that Markdown to a PDF through pandoc, a universal document converter. Basically converts the Markdown to LaTeX, and then LaTeX builds the PDF. In 2022, we started again, slimming the question set down from 72 to 48, and engaged in some real software development to build a framework for analysis. It took a lot longer than we planned, a lot. It was more than a year when we originally planned, about 4 months of development. But life got in the way for all of the volunteers. We all had various things come up, job changes, starting school for this one, and I had some stuff at work came up that just completely took away my attention for a few months. But we did the best we could for an all-volunteer team. Of course, not full-time engineering, because we're volunteers. So you can go download the report now if you want to. It's about 100 pages, but a lot of that's graphics. I'd say there's probably a solid 20 pages of prose, 20, 30 pages of prose with analysis. Proud of the work we did on this very scant budget of only about $1,200, and countless nights and weekends working together on this. And apart, because it's still the pandemic, you know. This is my sponsor pitch here. If you're interested in funding a serious sponsorship to make this happen in 2024, whether that be single-digit thousands up to multi-digit thousands, please talk to me as soon as possible. One of our core team members is currently looking for a job, and I would absolutely love to hire them full-time to do this. If we were able to get the funding to do it. But as of right now, Code and Supply is coming. We're like struggling to keep the lights on, literally, let alone be able to hire a data science team. If you don't have thousands of dollars sitting around in your company budget, you can help us afford more things like paying our people an honorarium or buying them dinner or whatnot by joining Code and Supply. It starts at about $10 a month. We have plans all the way up to about $275 a month if you want to co-work with us, and various other levels in there for whatever fits your budget. So now on to the meat of the talk, data engineering. I think I'm gonna quickly transition to the full screen for the stream, so they're not seeing just my face, because most of this was just face. The rest of this is going to be like slides, so give me a second. Usually I'm the one who's back here handling these transitions myself. All right, so the rest of this talk is going to be about the data engineering aspects of the product and producing the report. I'll talk about how we collected and clean the data, how we built software to analyze the data and produce tables and graphs for inclusion in the final report, how we helped ourselves by building tools to make all of this easier whenever we're just working with plain text most of the time, how we automated not only generating the report, but also testing our software, because we were still building software, so we have unit tests for our report. And what we want to do with it in the future. So I think this is you.
Yep. Okay, so let's talk about data collection. Primarily how we actually did this, we still had the 48 questions. We did this through Typeform. This Typeform is actually pretty good for long-term surveys. Pretty easy to actually for a user to get through, but it also has a lot of features that are very useful to us. Some of it includes just if a user abandons in the middle of the survey, we still have their data. While we didn't see that much really abandonment, that does happen at 1 to 5%. So it's pretty good that if someone just abandons in the middle of the survey, we still get at least some of the most important questions. One of those questions is, or pretty much the only required question of the entire 48 question is, what is your base salary? And most people thankfully gave that and more. Because after that, besides what your base salary is, we asked what is your expected total compensation? How satisfied with your job? all the different things about where the person lives, their titles, their roles, so on, all the really fun demographics. And so we spent a little time, like a month or two, just like waiting for this data to kind of just like roll in and collect. And then we got to the really fun part. Typeform gave us a really nice CSV. And my God, this is a very painful format, and that we really dread that Typeform gave us. And we wish for something hopefully better. But this is like a very classic way of data that gets sent out. Pretty readable, but has consequences. So, for example, questions that have multiple answers, those multiple answers get split up into multiple columns. And so at some point we have to somehow just bring them back together. And so that kind of made things a little bit wishy-washy. All the columns are named after like the questions themselves. So we have to like translate those questions into like more unified names. So it's like there's a lot of things that we have to do. And so we have to go through this whole one-time cleaning step. Most of the questions, thankfully, were done pretty well in the survey. That it just took some very basic cleaning to just bring them together. And so we had a lot of pretty easy data preparation steps that just kind of took all those columns that were multi-question, bring them into just one column with like some lists, so we can just basically making our lives a lot easier. There's only one thing that we had to do during the survey, because there was one exclusive question that was very painful, which was the expected total compensation, because it was free-form text. And people, instead of giving us very fun numbers, loved spelling out the full equation of their total compensation. So we kind of learned a little bit that maybe we should actually just ask, like, hey, what's your bonus? What's your stock? And then we'll calculate it for you and not have to worry about it. That was the only time we had to do some very manual, just like go in, actually just edit the CSV. But besides that, we had all these steps that we did in pandas to go clean through the data. And at the end, we spit out finally a file with a proper data format, Parquet files. If you don't know what Parquet files are, they're a binary format that stores data in this very nice columnar. There's like a lot of terms. Basically, data is really nice and clean in there. When I read it out, the schema is consistent. It can store all these really cool nested types, and allows it, all data tooling works really uniformly with it. Downside, you can't open it directly and read it like a CSV. And so a lot of these data preparations and cleaning and all these steps start out with pandas, but eventually we move to polars, but more on that later.
All right, so our base analysis workflow. We chose Jupyter Notebooks as our development and runtime tool of choice. It was my first time ever using notebooks in production, like ever. I think I played around with Jupyter a little bit back when it first came out. Like I think it was on either Reddit or on Slashdot years ago. So it was the first time I had ever really used it. And I think I recall Alex saying something, he was allowing it only out of expedition and anger. So that was a little bit of a flag. I found developing directly in Jupyter to be incredibly cumbersome. As somebody who has generally preferred an IDE for most of my career, with things like autocomplete, doc search, the finer parts of an IDE, Jupyter was just... It felt like a generation older way of doing coding. It wasn't really until I used VS Code's built-in notebook support that I found that I actually kind of like the notebook way. It feels more intuitive once I had a better focused code editor for it. I eventually, of course, found out that IntelliJ also has a similar notebook functionality. IntelliJ PyCharm being basically the same thing. Having done more with notebooks outside of this effort, since the effort concluded, I have completely validated the idea that notebooks in production is just not a good idea. There's too many edge cases. You're better off just doing your core development in the notebooks and then moving code into regular modules that you can import into the notebook, and then override methods, override functionality, pass in lambdas whenever you want to change the behavior of something. It also surfaces a better API. We wrote our code in Python, of course, because that's why we're here. Using pandas at first for data manipulation and filtration, of course. and then Plotly Express for doing our visualizations. Nobody's ever going to get fired for having chosen these tools. These are the standard tools of data science in 2024 and in 2015 and probably in 2030. But we know that there are things better out there. Somebody is working on them, and one of them we found, and we'll talk about that in a little bit. But first, a not so quick aside on data frame programming, because we're going to talk about one of those things we found pretty quickly. We started on pandas because we had to start somewhere, and we started out with something that was familiar to someone, Alex, because he wrote the first lines of code. Alex stubbed out most of the first pass. I found myself fighting the pandas API badly, mostly because of my lack of experience with pandas and because I was just coming back into Python after many years not using it. We started this in mid-2022. I had been on a Python team for about 6 months, having not touched Python since 2005. So had some things to catch up on. But I was okay with it because of my familiarity with Spark. I understood the general concepts that were going on inside of pandas because of pandas' relation to Spark. Similar concepts. That Spark familiarity had me briefly considering just like throwing all of the pandas away and just wholesale moving to Spark and using PySpark locally. But just about the time that I was starting to build up enough frustration to actually do that, Alex heard about polars at about the same time that I heard about polars. So we talked about it a little bit. He was glowing about it, and I was like, wow, this is actually a lot closer to the Spark API. This like works, and it's like there's like types and auto completion and like really good docs. Okay, let's do it. So we decided to switch. He ported over some of the stuff, and we just were like, yeah, this is a lot better. So pandas may shift a lot of operations to NumPy, but far too often it doesn't. And that's when you're stuck in the land of the single-threaded GIL and lots of sadness whenever things go kind of slow. I don't have any stats saved, like exact stats, because we didn't time it like that. But I recall that our pandas implementation with only about 20 graphics was taking on the order of minutes to run the graph generation code on this Chromebook, which is like a 8 gigabytes of RAM, 64 gigabytes eMMC storage, so it's basically a SD card for storage, and a quad-core i3 processor. Very entry level. This is a machine that has a keyboard and a screen. Slightly better than a potato. It would take order of minutes to run. Of course, this was rough on this, but it ran probably a minute or two on my gaming rig. It's like 32 cores, 32 gigs, SSD store, NVMe SSDs. Whenever we ran the same thing in polars, it ran at least 10 times faster. It was probably 20 times faster. One of the projects that I would later do to prove polars for another use case of mine, I saw 27 times speed up on this machine for analyzing the Allegheny County voter registration database. So it's definitely something worth something on that alone. It was something to look more into. Given that speed and the just overall friendlier API, more readable code, more testable and componentizable code, it was a no-brainer.
Cool. This is where I get to come back because I love doing polar propaganda. It wasn't exactly like a wholesale like switched over. Like we just go through everything and just limit. Like we have to get this done. We were taking way too long on the survey, so we mostly started to just redo some of our base methods for analysis, like the code for like loading in data and some basic filters, and then try to like start using polars for like the next graphics that we need for the report. And as we started using it, the developer experience of just using polars was very just quick and apparent. In my notes, I have literally just chef's kiss. It is that good. And there's a lot of reasons for why this is the case. And this is the insane list for polars. I say, like most innovations in Python, data engineering, and anything else, Rust was involved. This is like the classic story of like most of new programming things. Is like Rust just all of a sudden killed like made performance ridiculously awesome. But there's actually a lot of other benefits of polars, which we'll have eventually a code example to actually give you a better idea. But probably one of the two main points are just how you use it is a lot friendlier, I believe, and then the performance is just built in and it's for free. So biggest pro, expression-based API, which is kind of just basically builder patterns. So you have your data frame, you'll say like dot select columns, then dot filter, then dot. It's just you're just kind of like building up all these instructions. There's actually something really fun about that. Is actually if you have like a formatter, it will format since you're building this like really builder pattern thing, the code will just format and be very readable and very nice, and you'll soon get to see like how that actually like occurs, and it's just like a very natural thing. So like I've even seen it work when I use polars. A lot of time my code, once it gets formatted, looks really like most people can actually understand what's going on. And then on the other side of things, it has lazy evaluation and lazy execution. This is probably the most killer thing. And so in pandas, you're executing one step at a time, and that's just going to execute that step. In polars, I can call .lazy, and now every instruction I give it, it's not going to execute it yet until I say .collect at the end. What it does under the hood is then it will rearrange the instructions, putting them into the more optimal form for me, so I don't have to really think too much. I can still just write really probably bad instructions, and it'll just make them better for me. And because it's using Rust everything, it's parallelizing all the stuff under the hood for me for free. This is just kind of just free performance wins. I don't have to really think about it. I can give this to a data scientist, and cool, their code is actually performant and readable. That's kind of a really shocker for data scientists. Other just like fun advantages, few dependencies. Pandas depends on a lot of other libraries, like NumPy is just the base it has to depend on, because that's what it's built on top of. Polar is just on the Rust implementation, nothing really else. You can have a path if you really want to go down in the Rust path. Obviously, there's the Rust equivalent of the Polars library, since it was all made in Rust and kind of just binded over for Python users. And then you get all your nice like type hints, really good docs, etc. There are some cons. It is definitely less battle tested. This is something that I run into frequently as a frequent user of it. They haven't exactly reached a stable release yet, which means they love doing API breaking changes. Not too frequently, but it has like annoyed me when they do things like renaming group by as one word into group_by. Really annoying, a little bit painful, but it's fine. The good news is that 1.0 release is actually on the horizon, thankfully. So actually a full stable release that has less of those changes is actually coming, and that's pretty welcome. And it's to the point where I think I'm more comfortable with people in even my own company using it without having to run in these weird issues when we upgrade the library. And the other downside is the learning curve, but I think even for people who use pandas, it's also very cumbersome, and I pretty much always open up the docs anyways for it, so I figured, you know, even if it's a learning curve to learn this, we'll say either way, we're opening the docs of one library or the other. Not too much of a big deal. So let's go to, let's learn on this fun little tangent. So main thing probably to just keep in mind about polars versus like any other library, we're going to show example of it against pandas. Its main target is not really to be like this friendly library. It's mainly to be a performant library and be like actually the best tool for a single machine, to the point where they're slowly working up the features to do it what they call out of core, which just means that you can operate on data that's larger than the resources you have. So that's actually like, this is like the grace in between like pandas for very light work and having to start a cluster and use Spark, which is or Dask, or I don't, the moment I hear cluster scheduling workers, I am just done for, I don't want to deal with it. So this is like the most amazing in between that now kind of exists. So let's start getting into a real world example.
Some real world examples. Oh, you know, I should go full for this so that we see the full slide for the code. Because we're going to put code on slides. I talked a little bit earlier about having done some analysis on the Allegheny County voter registration database, and that's like my really base entry level example that I like to show people. So this, of course, is pandas. Just about everybody who's worked in pandas recognizes this pretty quickly. This reads a CSV file and then filters down to Wilkinsburg's municipal code. I live in Wilkinsburg. Further filtering by the date last voted and then political party. My biggest problem with pandas is the array reference structure. I've never cared for that shorthand. It's always felt kind of odd to me, and it's very foreign to somebody who's not familiar with Python's syntax for and I'm missing a word here. The syntactic sugar for effectively calling the attr method.
Get item?
Yes, thank you. Also, somewhere in here there's a bug. I challenge you to find it. This code actually doesn't run. Pete might be able to do it. Pete's a walking Python compiler.
I thought the code looked good, but he said, or maybe like we actually don't know if the bug is fixed or.
Yeah,
if
I may have
is...
actually fixed. I have in my notes spot the bug, but I may have actually fixed the bug somewhere in here, but that I can't tell just by looking at it is a problem.
Yeah, I don't really write a lot of pandas for exactly the reason you just said.
Exactly. This is the exact same method, does the exact same thing, but in polars. So you can see instead of like a read CSV, we use scan CSV. Scan CSV is Polar's way of creating a lazy data frame, or as they call them, a lazy frame. There's a few more parentheses in here, primarily to allow the multi-line formatting that Python doesn't really let you do unless you group it into a parentheses. But it does the exact same thing. Read, and then run a bunch of different filters and select some data, and then call collect. Collect turns it into an actual data frame.
Yeah, I actually think a pretty cool thing about the scan doesn't actually read any data. It kind of maybe just reads like the header of the CSV just to get an idea of what columns exist. It doesn't read anything else besides that. It's only when the .collect gets called, it then starts actually reading row by row, and it's going to start applying these filters directly as it's reading. CSV is not the greatest format, but if it's like a more binary, more data-tailored format like Parquet, this might skip entire chunks of data to read entirely. It's just built-in efficiency when you just read data lazily like this.
One of the cool things added in a more recent version of Polars, and actually I had to change this for the slide. You'll notice that the pl.call calls within the filter calls. Polars just recently added a feature where you can just use the name of the column as long as the name of the column is a valid symbol in Python. Previously, it was a method call and you had to pass a string for the name of the column. So it's like kind of a cool automated way of being able to reference your columns. You may not necessarily know that they're there, but if you know that they're there, then they're accessible to you through in the Ruby world it's called an open struct. I don't know what's called in the Python world. Never learned that word. But before that was available, we came up with our own solution that effectively did this. We put all of the columns that we wanted to use inside of as constants inside of a class. It made it very easy to know exactly what columns we were going to have because we had already done the work to create the pl.calls for all of the columns. Then we got autocomplete out of it too. Did I actually say everything I want to say there? Just about. Yeah, close enough.
Cool.
Back to you.
Okay. And get back to now. So that's like a little just tour of like actually seeing the difference in reality. And I think hopefully you can see like a little bit of like what I mean by like readability. And actually I think some of this calling like dot filters cleaner than trying to do like df equals df column equal. That's a bunch of nonsense. But there's some other things with this lazy execution that's pretty nice. Because it's like a builder pattern, you can kind of just start layering on these instructions And so, like, one of the big things we did in the Jupyter notebook is we'll have like this read data call, or maybe we'll have like a fancy function. So maybe like in our case, like DF0 is we're filtering for full-time workers inside Pittsburgh only because that's most of the results we got. So we kind of want to restrict it down to just our region specifically. And then each specific cell for each graphic we're doing might have additional filters of like, I only need these columns and I need maybe I need to do some group buys and stuff like that. And so it kind of allows us to then start to like build these more individual, just like kind of like work plans of what needs to get done. And then all we're really doing is just calling .collect, doing a to pandas conversion because at the time Plotly only accepted pandas. Now that's changed thanks to something called the data frame interchange protocol. What a fun name. Where it just does that for us, but now we can just pass in polars directly in. It'll just do that stuff under the hood for us. It's pretty awesome. And so this is actually how we're getting a lot of like the massive speed ups, and actually we're getting a really better workflow because now for each notebook cell, for each graphic, we just call, okay, read data. I put all my basic, or I maybe will have some basic filters, so I have a more specific function. I'm now trying to say like, oh, I need to find all these group by this gender, and then find all the quartiles of their pay. All these kinds of things are now made really easily, and this is actually how we started to pick up a lot more speed of trying to get through the report, unlike pandas where we're just constant just writing really janky code throughout the entire notebook. And so that's most of the data frame stuff. Now onto the other tooling.
Yeah, so as Yvette, one of our other writers who couldn't be here tonight, and I did most of the writing, we needed a way to ensure that we were using the graphs that we were generating and to drop graphs from production that weren't useful. You know, why spend even 10 milliseconds creating a graph that we're not going to use? This also helped us ensure that we made all of the graphs that we wanted because we had this huge spreadsheet of all of the, you know, cross this with this, cross this with this, okay, mix in this, add this as a dimension, make this a color that we wanted to have and track what we had left to do, especially when we started, when we did the pandas version, we had about 20 graphs. By the time we ended, I think we had around 80 some in total. And there became this mad dash at the end where we were also just creating more graphs because we got more intimately familiar with some of the data that we were working with, and we realized there was more graphs that we wanted to do. Code and Supply uses GitLab. We've been a long time GitLab shop, so of course we use GitLab CI to do literally all of this. That was our cluster was GitLab's workers, GitLab's runners. For executing, we use Papermill to execute the notebooks, which we found to be less than desirable. The development team was pretty slow to respond on some things, including a big bug that I ended up just kind of working around by turning off a feature inside of our code, like reaching into their private API to do it. So we'd really like to eject Papermill from our pipeline whenever we get around to it. We had to switch to using a thread pool to do all of our notebook generation in parallel, or at least in parallel, because of some problems with how Papermill worked in CI with the process pool. It's a bug we were never able to fix, and the Papermill team never weighed in. Lastly, of course, I talked a little bit earlier about pandoc. We used pandoc again to build the final PDF. Writing in Markdown is always a good time. I've given a talk about writing long scientific papers in pandoc previously. It's called A Documentation Workflow Loved by Engineers and Data Scientists Alike. Given it at a few different conferences, so you can go find that on YouTube or on FOSDEM's website for FOSDEM 2021. Lastly, frankly, Make facilitated all of this. Just good old-fashioned Make. We were able to have a gaggle of Markdown files, multiple different directories for where things lived, whether they be the notebooks lived in one directory, the report lived in another directory, some graphics lived in another directory, and we could just let Make figure out the parallelism that was necessary to actually go build everything. It was really cool. We intend to reuse the software for the next compensation survey, whenever that may be. Probably going to be in 2024. We might wait till 2025. We'll see. We'll iterate and continue creating more convenience for the developers, which is us right now. If you want to like keep your eyes peeled out for the compensation survey working group whenever we spin that back up, if you're interested in getting into what I think we could probably call it a mature code base.
Yeah.
Mature in the way a 13-year-old's mature. It's got a lot of room to grow. It's got good bones. And we would love to have some other people coming in and taking a look at it and helping us also with more visualizations. We didn't have time to get into any of the geographic visualizations that we wanted to. We would love to be able to do that next time. And then, I think you talking about this for just a moment.
Yeah, I mean, a lot of work was done to actually make and create a lot of the graphs, and pretty much most of the feature work is just as much pandas as we can eject all of the pandas from the project as fast as possible, so that we can now have a more just like uniform pipeline of how everything works. And so now let's get into actually seeing some of the code from the project to actually get an understanding of like what have we been talking about this entire time without showing any example of. And some of these things are like, so previously in the example of polars we showed, the way polars you reference a column is by, you will import polars as PL, so you'll say like pl.column. Actually this is basically it. We actually realized as a fun pattern that you can do is just, as Colin said, in what we were doing was just making a class of just constants. Advantage, your code editor now knows all the columns. So now we start saying columns.user, and then it'll just show you, you're getting these like free autocomplete things. This is all this was for. It was just like a fun pattern to actually realize we can just now have a lot of free autocomplete. And probably easy to do some quick code gen of just like, here is my data, just generate this Python real fast, and now I get to have just free type hinting, or I get free just like autocompletes while I'm doing data analysis, which is super nice, especially because given we probably had like 50, 60 columns is way too much context for us to remember. It was very, very painful to think, I need to make a graph. Oh God, what are the columns I need every single time, over and over again.
And then we were also, as a part of that, we were also creating columns on the fly, because that's just part of normal business. So what happens whenever we want to create a column on the fly and then propagate that column with the rest of the data forever? Oh, we'll just throw in the columns, and then we'll create a selector like this that is able to make that new column always available. And that's exactly what we did. We saw the success of this columns class into which we were putting all these constants, and made a selects. So we could just pass these select statements around. You know, think of it as like copying and pasting little bits of SQL, or you could do something very similar to this in pandas, but it's not going to read as nice as polars is in this particular case.
Yeah. Plus, I mean, like this is like the advantage of like polars and how you can just build up all these operations. We build a bunch of operations, and clearly there's no data to go for these operations. Eventually, this will end up with the data and get computed together. But also just say something else just really interesting, because we have some cool polar syntax on there. I know a lot of time that in pandas, if I have to like change a column that previously was like this Boolean column, in this case, career is manager, I would basically have to call it the .apply function, which is the biggest killer of all performance, and then write a lambda function of it, just a one-liner statement of if true, string is manager, else IC. This is the polars equivalent, which is fun because it kind of looks like SQL in a way, just more spelled out. And now, since it's now in the polar syntax, hooray! Actually, this will now get distributed and compute really fast. These are the kind of things that like polars is just like exposing, which is like things we already had in other data manipulation languages, but just pandas, unfortunately, was just kind of stuck for being a decade old.
So while moving to polars, we wanted primarily to get away from pandas reading any data. We knew that the speed increases of polars were largely in part to at the scale of data that we were working with, which I think we're talking like maybe 100 megabytes tops, maybe even less. So really not a lot of data. When we wanted to read data, we wanted polars to be doing that because it might only need to read 1 or 2 columns out of the entire Parquet file that we were reading from. The read performance of polars was just so much better. We had to get the pandas read stuff out. I think I just said that a couple times. Anyway, we used deprecated extensively while we were rooting out all of the pandas code. Deprecated is a library you can install. It's been around for a long time. I think I have code in it. It's an incredibly useful construct in general. Scala has deprecated built into it, and that was something that I had used extensively in Spark whenever I was refactoring. Even if it never actually got committed, it was always great to have it there because your IDE could show you, hey, you marked this as deprecated. Are you sure you want to use it? And I think Pycharm might do that. If anybody from the Python core team is listening, please put deprecated into Python in the standard library would be my big ask. Pete says no. This is an example of a much longer query. We're checking in here that the column is actually a data frame. That the column that we want is actually in the data frame. There's some possibilities when we were manipulating our data that maybe a column got chopped off. This shows a really cool thing about that pl.call return value, the expression that is a column. You can look at its meta object and be able to get the column name out of it. So anytime we needed to get a column name back out of a column object, do a little incantation, we get the string back out, and then be able to do things like, hey, is this column actually in the list of columns? There's a nice little guard system for these more complicated methods. Later on, we're getting some job titles and counting them, ordering by the count, reversing, and then getting the titles. And we use this to pass the labels into Plotly, so that whenever we drew a histogram showing job titles, we put the job with the most titles on the left and the least on the right.
And it's still all lazy even through the count, everybody count.
Yeah.
Yep.
That's great.
It's fantastic. Okay, and now something that I realized we didn't explain when we said put notebooks in production. We mean literally the way the graphics are generated is there are Jupyter notebooks and they will get run in part of the pipeline. And this is the main function that does all that work. So the library is called Papermill, and a lot of the knowledge of Papermill mostly comes from a Netflix blog about how they productionize notebooks, because they found that it's a somewhat decent way of data scientists and data engineering collaborating. I think it's just a skill issue of data scientists to just not write code in just regular Python script, but to each its own. But the Papermill library, with its faults, is actually still kind of nice to use. The main line to look at is the pm.execute notebook. The first thing you give it is the notebook that you want to execute. The second is actually where you want to output the artifact of the notebook, because it's going to actually run the notebook, and it's going to that output is going to have all the output of every single cell of what it actually rendered along the way. The parameters is another nice feature where inside your Jupyter notebook you have to put a little bit of metadata on a particular cell at the top that you create. And so that cell usually just has basic parameters. And so one of the parameters that we had in all our notebooks by default was write image artifacts being false. This just means when we're using the notebook, and I'll explain later what that means by write artifact and where that was coming into play. But every time I was generating graphics, it wasn't writing them out. Only in the production pipeline, I actually wanted that when it renders the graphic, actually save it out so that we can use it in our PDF, and then also give the actual path it should be rendering all those to, so that everything is consistent. And so this is just a little bit of actually using Papermill. I don't quite recommend it. I think people should write proper scripts. But you know, if it ends up being the case of like data scientists just love using Jupyter notebooks and they can document them really well, maybe it's a happy medium.
I think if we were to go back and do the paper mill production notebook thing again, we might, instead of having one Python process that fires off a bunch of threads or a bunch of processes to go do paper mill, we would instead use the make file to handle a single Python process running a single paper mill
I
execution.
guess it's just how to distribute the task. But basically, we had a lot of notebooks, and we just trying to find how can we run as many notebooks in parallel so that we just get done with it.
Right. Here's an extract of a refinement on data salary to a graph that of just the expected total compensation and years of experience to a certain configurable level. We played with this a little bit. It was kind of nice to be able to find the right level of data that told the story that we wanted to. I think initially we had an X of 10 years to show a graph of just the people under 10 years of experience. But then we found there's this weird line between 8 and 9 years. So let's do 8 and then put everybody else in another graph. You'll notice here, as we've been talking around, the collect method is there. That's what actually turns it into a real data frame instead of just a lazy frame. So the filter is pretty basic, so is the select. That only full-time within range does a lot, actually, because that creates a lazy frame that has already read the data, filtered down to a base compensation range that's within minimum wage and an upper limit that we used for the entire data set. I think it was like 400,000. So chopped off the 12 people who had more than $400,000 base salary, and then also filtered by full time. So a lot of the times within our salary analysis information, we called that method to get our data because it was going to pre-prepare all of the data,
Yeah, I mean, it's just it gives us consistency. So like because basically this is like how every Jupyter notebook cell was looking like. Is like we just start off with this data as our base because it ended up being like as we were doing pandas, we were kind of copying and pasting that exact code over and over again, and we were not being really consistent with like what population of people from the survey are we working with. That just does it for us, and we're not thinking about it anymore. We're kind of just getting to the meat of what do we need.
Yep, and those kinds of things fit perfectly inside that selects class that we'd shown.
Cool. And then the other half of the cell, first part, ignore it. It's just me doing some plot. It's just me making a plotly figure. That's all that is. There's some fancy methods we made to like make the title look standardized and all these things. The real key is the last line. And this is something that we made particularly. Submit figure is basically we'll take in the plotly figure and a name, and this is what actually does the whole rendering. This is where my parameter of write image artifact comes into play. This method actually will take it in, and this also has like other parameters of like adjusting the height and width, and so we're kind of then rerunning the cell over and over again. We're seeing if it looks good, and then finally we are rendering it out so that now whenever we're building the report, the rendered out image just gets shoved right into the PDF, and that's it. This is basically what completes like the whole pipeline of just like how do we actually make one graphic. It's just like data, experiment with the viz for endless countless hours, or well, probably like tens of minutes, not like that long. But and you just throw it through the submit, and that's it. Next graphic. And so this is our fun slide if you ever want to go further down the rabbit hole. But
Yeah, I think we're getting pretty close to time, so we'll skip going down. We have this in here just in case we wanted to actually load up something and really go down it, but we're at time. We're getting too close to time, so I think we're gonna skip that. So go if you want to, and I really suggest that you do. Go download the report. Consume it not only as a data scientist or a data engineer who is critiquing a product and a process, but also because like this all has information about your career in it. Regardless of where you are in your career, there's information that's going to be interesting to you and relevant to you. Whether you are trying to determine your own rate as a freelancer, or you're trying to argue for a raise, or whether it be at your current company or as you're negotiating for your next job, we want to give you the tools to be able to make these kinds of arguments, to make these kinds of asks. The hardest thing that I found early in my career was understanding my value. I didn't understand my value until I was probably, I don't know, 31 or 32, based on just the simple math of the value that I was creating for my employers. So I wish I had had something like this whenever I was just starting out, and now it exists. So take it, pass it around, and help us find problems with it. You know, as scientists, we want people pointing out the problems with our work constructively. Please don't throw tomatoes at us. But that kind of feedback helps us get better, not only to be able to serve people better, but also to help us improve. And that's what Code Supply is about: helping everybody build community together, build software together, so that we can make everybody's lives better. Oh, and then I've got my one more pitch in here. Again, if you want to make this happen again, we need money. So whether you have a few $1,000s available in a corporate budget, or you've got $10 in your pocket, we've got a donation box over there. You can sign up online if you want to give monthly. Again, one of our survey team is currently looking for work, and if we were able to employ them full time, we could do this constantly. We have had some dreams of being able to do a kind of constant Code and Supply survey report. It's like maybe looking at an 18-month window and just constantly generating a report. So that would be really cool. That's it. I do have one thing, if I can get it to work. It's a little janky on this laptop. I wanted to show you the paint drying. Unfortunately, ASCII Cinema, there's just enough of a delay between when I move it and when it shows up here to completely drive me nuts. So you can watch it run. Quite literally, this is me running this last night with an ASCII cast, and it runs relatively quickly. You can see it going.
I see every graphic.
I still find it really interesting. All the graphics are PDFs.
Yeah.
I don't understand how that works well with pandoc, but sure.
Yeah, the PDF thing is just an idiosyncrasy of LaTeX conversion to PDF. It's easier if a source graph is already in a PDF, it can just be like inserted rather than having to be re-rendered.
That makes sense. Okay.
Very common to use SVG instead, but then you have to pre-filter to PDF or to TXZ or some other format.
PDF easier.
PDF's a lot easier. Just deal with PDFs. But we did spit out PNGs at one point, and just realized,
But it's done. That's it. The report has been made.
Yeah. The whole thing takes on this machine takes about 3 minutes tops, and I set ASCII Cinema in a way that it will trim out waits of more than 2.5 seconds. But even then, it's mostly just going. So let's come back here. I don't know.
Cool.
And a little bit of just resources if you want to go learn more about polars.
Try out polars, please. It's like I actually don't know how to Polar's performance is very, very crazy. Even today, I got 2x speed up on a thing just because I finally was able to remove the pandas from the code, because I had to load data in pandas, convert it to polars, do all my fun stuff, then convert it back to pandas, which is tragic. Now, at work, as I changed up all our tooling, it's all polars now. I don't have to do anything anymore. I also saw there was some we were trying to detect when our so I work at a self-driving company. So most of my day is just figuring out like, hey, when is vehicle doing X? And one team's tooling took on a pretty sizable chunk of data, probably like tens of gigabytes, 30 minutes to process and just get all these events of when we're like changing lanes, because the vehicle doesn't actually know it's changing lanes. As like a fun aside about self-driving cars work. And then I was like, you know what, for funsies, also I want to convince him to use polars. I'm like, I'm going to spend time rewriting this. And so I rewrote it, and it ran in 2 minutes, which it wasn't just like 2 minutes, just like, oh, magical, like, 15x speed up. It's like, well, no. So they have this whole thing where they have raw data, and then they make this extracted nice data set. And so that was 30 minutes on the nice extract data set. This was 2 minutes on me using the raw data and having to compute everything on the fly. So it's actually even more insane level of computation that's actually occurring, but still it's 15x faster, loading data from the cloud storage down, all this. It's been fun. Also, I want my code finally cleaner. People can read my code. I've tried to review people's data science code, and I cannot believe there's other ways to create columns in pandas. I swear there's like 15 ways of doing things in pandas. It kind of pains me in my job. But that's my argument for use it. But that's it. Yeah.
Thank you. I think we can take questions for a brief period of time. I think we've got. It's 8:05 now. We can stick around for probably a good 20 minutes or so. Maybe take 2 or 3 questions if you have them. Anybody? Robert.
Yeah, it was interesting how you said that Polaris got this great middle ground where pandas is the single thread thing. At the other end of the spectrum, you've got this vast, multi-machine thing, and Polars is this nice middle ground. Is that like a summary of what you guys are pitching, or?
Yeah, that's like the summary of it. It's just
You can disagree. I mean,
I would say Polars really hits the already currently, and maybe even 2 years ago when we started this, hits the case of being the best single machine platform right now.
Yeah.
There's nothing better right now.
Especially because even its scale, like you go to the website, they show you all the benchmarks. They're like, yeah, they can process like 50 gigabytes of a join in like 3 minutes, which is kind of impressive. And even in my experience, like the stuff I was rewriting today, it's processing 10 gigabytes per like run, and we distribute our task out. So like it's processing 10 gigabytes of file data. That ends up being like could be like 20, 30 gigabytes of like actually it is really good at a single machine, and it's doing a single machine extremely well. It can do it makes a single machine even more capable than it really should be in some cases. But I guess maybe we just underestimated how much performance we can actually get out of a computer.
Yeah, it will. In the winter, I use my gaming rig in my office to heat my office, and so I remember at some point just continuously running that just to see how hot it could get my CPU, and see if the CPU alone could generate the heat that I wanted. I didn't need to like keep a game running in the background in order to keep the GPU also hot. I think I might be speculating a little bit here, but I think like Polars is more bound by your disk speed on startup, like how fast it can read from a fast disk.
Yeah, and I think it's also, eventually it hits like a CPU bound, because, yeah, this is the mention of like the GIL and single thread. So Python, unfortunately, it can only do a single thread of execution. Because all this is in Rust, and it's using this other library on Rust called Rayon, which I'm like, wow, another way to call something a thread. That's so cool. It literally, like, I look at my CPU and I just see everything firing at 100%. So it's fully utilizing it's basically trying to chug as best as it can everything it's got at its disposal, and the limitations like the first time read of data.
I think that like the promise of Polars to do out of core stuff puts it within like striking distance of being able to take on Spark.
Oh, I mean,
It's still some time away. Spark is
Still dominant.
Dominant. It will be dominant.
Polars is coming for it.
The Polars is there.
The other reason probably I'd back Polars is because they just got like $4 million of like funding for this library, because the next objective when they do out of core, it's going to be out of computer. So they're going to basically get into the territory of all the fun libraries like Spark and Dask and all this stuff. But for now, it's doing a good job at what it's doing, so can't complain.
Take another question or two. Anybody? Connor.
Is the underlying data available in some redacted form?
We've thought about that, and we would prefer that people join us on the compensation survey working group team to get access to the data, and then we give it away pretty freely, the raw data. But we're just so paranoid about anybody being able to unmask somebody, because Code and Supply simply doesn't have the resources to deal with the fallout if somebody were to get unmasked.
Even in the CI pipeline, the data is like, we have the data in the repo, but it's encrypted. And so like the pipeline only temporarily can just like decrypt it, run through everything, and then junk it away. So even we took security in the pipeline itself.
Right, and for a time we actually were running our own runners, our own GitLab runners. It wasn't guaranteed that the jobs would run on our runners, which was quite literally my NAS, a VM running on my NAS. But we wanted to make sure that was available to us if we decided we wanted to go to that level of security. And then my little quad core Atom, Intel Atom NAS with 2 gigs of RAM would be building the server.
Right.
So efficient.
Not gonna eat your off for that.
No, it's gonna make the dog room a little bit warmer. Any other questions? Thoughts?
It's really interesting the parallels that are happening here on like single node and the tooling that also are in the more like analytics space, where people work with more like, as opposed to data frames, it's more SQL oriented, and so like tools like DB and
Oh yeah. No, I already mentioned.
I'm just late, huh?
No. Okay. No,
We didn't talk about it tonight.
It was like last night because we're preparing these slides. Because I've been seeing things like the very interesting proliferation of new data engineering tools and analytics tools in the Python just because of Rust. Almost. Well, DuckDB is not that case. DuckDB is C++,
For everything.
but for everything else, because there's like libraries like Data Fusion, Delta Lake. There's a lot of really weird, cool nonsense out there that's like slowly popping up, and it's kind of getting me excited that maybe someday I would see the demise of Spark and Pandas, but probably got another 2 more decades before I see that happen.
Yeah,
So
I was more from just the perspective of like performance on a single machine for like reasonably sized data sets, where reasonable size might be 10 or 20 or 50 gigs,
Yeah.
Whereas, as opposed to like, as you said, like cluster is like the second worst thing an engineer can hear say. First is on-prem.
I've seen so many different.
It's like interesting because like I come at more analytics, I like seeing that way.
Yeah, enjoy Dask clusters and everything.
It's very exciting for me as somebody who has learned and relearned Rust about 8 times now since 2013 or so, to also see a gateway to accelerating things. Not only can you use polars and effectively be using using Python as a Rust DSL effectively, just like Python has effectively become a C DSL for dealing with SciPy and scikit-learn and TensorFlow and whatnot.
PyTorch.
Now we're seeing that with Rust, and it's actually far easier to write the Rust interface, the Rust integrations with that.
It's like the summary, just Python's just a prey language, not a performant one.
Yeah. So if we
Performance
can
elsewhere.
also give people a gateway into the form and structure and guarantees of Rust, then maybe we can get data scientists writing Rust code eventually, or at least
Doubt.
getting to the point where the code for high speed data analysis is approachable for data engineers to migrate to a more memory safe language.
Or Polars is just letting them write it the correct way the first time. And then problem solved. We all benefit.
Yeah, it ends up being an abstraction on top of an abstraction on top of an abstraction. Thus, abstractions. You can come into my conference. That was completely unplanned. But yeah, that's all I got. Thank you very much for coming.
Thank you. Thank you.